Hey, welcome back. This video we're going to show you how to work scientific notation problems and just learning how to convert to scientific notation from scientific notation and correct any incorrect forms of scientific notation. Before we start though, we need to redefine some key components of scientific notation. First is scientific notation must have a mantissa. A mantissa is a number between 1 and 10 that has a decimal place. Then scientific notation must have what we call a characteristic, or the number 10 raised to the power of another number. That number that is the exponent or raised to the power of can be positive or negative. So let's start with our first type of problem, which is converting numbers into scientific notation. So we have numbers in standard form and we're putting them into scientific notation. The steps for solving these types of problems is that we first need to make our mantissa. We do this by moving the decimal place to the left or to the right in order to make a number between 1 and 10. If we're not given a decimal place, then we just put it at the end of the number and then move it. Then we use the number of spaces we moved our decimal place to be our exponent and our characteristic. So if we moved it 3 spaces to the left, then that's going to be a 3 in our exponent. Now, whether we moved it to the left or to the right, that will determine if our exponent is positive or negative. If we moved our decimal to the left, then our exponent is going to be positive. While if we moved our decimal place to the right, then our exponent is going to be negative. So, let's try these numbers out and convert them into scientific notation. 1354.0. First thing, in order to convert this to scientific notation, I'm going to move my decimal place 3 spots to the left. This is going to give me 1.3540. Okay, so I moved it 3 spots, so that's going to put my characteristic as 10 raised to the third power. Because I moved it to the left, it's going to be a positive 3. So if I combine these together, my scientific notation for this number would be 1.3540 times 10 to the positive third power. Okay, so we have 0.0125. In order to make this number a mantissa, we're going to move our decimal place 2 spots to the right. Because we moved it to the right, our exponent is going to be negative. And because we moved it 2 spots, our exponent is going to be a 2. So we have 1.25 times 10 raised to the negative second power. Let's do our third and final one for this type of question. 215.5. In order to make this a mantissa, I'm going to move my decimal 2 places to the left. Because I moved it to the left, that means my characteristic is going to be positive. And I moved it 2 places, so it's going to be positive 2. So this gives me 2.15 times 10 raised to the positive second power. So that is converting numbers into scientific notation. Now let's talk about the rules for converting numbers out of scientific notation, or basically to standard form from scientific notation. With these type of problems, we want to look at the exponent of the characteristic first. If our exponent is positive, then we're going to move our decimal place to the right that many places. While if it's negative, we're going to move it to the left that many places. From there, we should be able to get our standard form of a number. Remember, if you run out of spaces, when you add decimal places, make sure you put zeros in those empty spaces. You'll see what that looks like in a bit. So we had the number 6.34 times 10 to the second power. How we look at this, how we convert this into regular notation, we look at our characteristic and see its exponent. It's a positive 2. That means I'm going to move my decimal place 2 places to the right. This gives me a number in standard form of 634. Our second one is 5.231 times 10 to the negative third power. Okay, we look again at our exponent of our characteristic. We see it is a negative 3. That means we're going to move our decimal place to the left 3 places. Notice we run out of spots or digits to the left of the decimal. All we're going to do there is fill those empty spots in with zeros. So this gives us a total of, or a number in standard form of 0.005231. Okay, remember, negative exponent, we're moving to the left. Fill in any zeros. Our final one for this type of question is 2.453 times 10 to the fifth power. We have a positive 5 as our exponent. That means we're going to move our decimal place 5 spots to the right. We have empty spots because we only have 3 digits to the right of the decimal, so that we fill those in with zeros, and that's going to give us a new standard number of 245,300. Okay, so our final type of problem that we are going to see with the scientific notation is correcting any incorrect forms of scientific notation. With these types of problems, basically, you're going to have an incorrect form of a mantissa. So we're going to have to correct a mantissa and get it between 1 and 10 and make it a decimal number. More than likely, that's where your issues are going to be. To fix this, we're going to move our decimal place to make it a proper mantissa. So we might have to move the decimal to the left or to the right. Here's the key thing. If we move our decimal to the left, then we're going to add to our existing characteristic. While if we move it to the right, we are going to subtract from our existing characteristic. So let me show you how this works, and we work through a couple examples. 23.47 times 10 to the third power. To make this work, we are going to have to move our decimal to make a mantissa, a number between 1 and 10. This means we're going to move our decimal place 1 spot to the left. That's going to give us 2.347 as our mantissa. Because we moved our exponent to the left, we are going to add to our existing exponent, which is 10 to the third. So we moved it 1 spot to the left, then we're going to add 1 to our existing characteristic. So this gives us a new scientific notation, or a correct form of scientific notation for this number would be 2.347 times 10 to the 4th power. Second one for this type of question, 0.0125 times 10 to the negative 4th power. In order to make this a proper mantissa, or a number between 1 and 10, it's a decimal, we're going to have to move our decimal place 2 spots to the right, and that's going to give us 1.25. By moving it to the right, we're going to have to subtract from our existing power of negative 4. So, negative 4 minus 2 is going to give us a new exponent of negative 6. We put all that together and we get 1.25 times 10 to the negative 6th power. So our last one for today, 0.992 times 10 to the 3rd power. Once again, we're going to move our decimal place to the right, but this time only 1 place. That's going to give us 9.92, which is a number between 1 and 10. Since we moved it 1 place to the right, we are going to subtract from our existing characteristic. So we had 10 to the 3rd power, so 3 minus 1, that's going to give us 2. So we combine those together, and now we get 9.92 times 10 to the 2nd power. Now that we've worked out the 3 types of problems that you would see when working scientific notation problems out, you should be better prepared to handle at least these basic types of problems. Hope this helped you out, and keep up your good work in your classroom. I'll see you next time.